So I am going to go over first what you just explained to me as your solution.
My very bogus solution.
Not very bogus. It's very.
That's what I would call it.
Well, anything that gives you the wrong number is bogus, right? So you said that you were going to turn it into this problem, and you said you're going to say, all right, 1/2 is equal to 50 over 100, right? And so essentially, you want to fit as many things as you can right here that are of the form, let's call it x over 100.
Okay.
Right? Okay. And you said, oh, well, x can be 49, 48, all the way down to 4. Okay? And you said there were 47, and I say there's actually 46 available, because you probably forgot the strictness of one of these.
Oh.
Okay, so how do you know there are 46?
46 isn't the right answer.
I know it's not the right answer, but it's the right answer assuming you're using...
Assuming I'm right.
Right, this method. But the reason why I wrote the question the way I did was you're answering a different question. You made up a different question. You're answering exactly the question, how many x's there are.
What is the question?
The question is asking about numbers that belong in a denominator. You just changed the question. Right? And so think about this. Here's what happens. Well, I don't even know. Oh, okay. All right. So we're always exploring technology. That was us having a candid moment. Not sure what was going on. So think about this. If I am forced to look at exactly the problem I'm given, what is the first number that fits where the question mark is? Knowing that question mark is equal to 1 over n, not x over 100.
Okay.
So what's the first n that works?
The first n that works is 3.
Exactly, right?
Wait. Did it say it had to be whole numbers? Oh, yeah.
Yes.
I was thinking 2.2 or something.
The first one that works is n equal to 3. Okay, let's compare that to your old method.
Okay.
What happened with your old method was you started at 49 over 100. Okay, well, let's convert 1/3 into x over 100. Actually, you should have started at something like 33.3 repeating over 100, whatever that means.
Okay.
You see what I mean? The first number that works, according to their recipe, is not 49 over 100.
It's 3.
It's 33 over 100.
Okay.
Do you see what I'm saying? So that just shows you, that illustrates the total difference in the two methods. But even so, that doesn't tell us what works. What we need to do is we need to say, all right, 1/2, that's bigger than 1/3, and a bunch of other stuff, right? And our whole list is going to end somewhere, and it's going to end right before we get to 3 over 100.
Okay.
So now we got to figure out what happens right before 3 over 100. So how are we going to do that?
4 over 100.
But that's not of the right form, right? 4 over 100 is actually 1 over 25.
Oh.
You see what I'm saying? So we are forced to use the numbers the way they... It's like here common denominator is illegal. You can't do it because it's not what they're asking.
Evil.
They're actually, I mean, it's a little bit strange to think about it, but they're specifically telling you in the instructions that these do not
Most times people
have a
say
common
use
denominator.
the common denominator. This time they're saying don't use it.
Well, they're saying, yeah, exactly. So, all right. So we need this thing right here must be of the form 1 over n, right? So we just discussed not 4 over 100, which, as it turns out, is equal to 1 over 25. But like, we can do better than 1 over 25 when we're using the form 1 over n. Okay, so if we're using the form 1 over n, what's a number that is close to this?
What's a number that's close to this?
So we got to do 1 over a number.
Okay.
Pick that number.
1 over. Could it be any number? Yeah.
So think about this.
5.
1 over 5. That would be like 20 over 100.
Really? Yeah, that would work.
But that's not close. We want to get close. Right?
Let's see, 1 over.
Think about changing the denominator. Think about changing the denominator of 3 over 100.
What about 1 over 20? I'm getting closer.
1 over 20, well, yes, you are. 1 over 20.
That's 5 over 10. 100.
Right? So what about, so think about this. Think about, don't change the 3. Change the 100. How do I make this fraction a slightly tiny bit bigger?
Slightly tiny bit bigger.
Do I make the...
99.
There we go. And 3 over 99 just so happens to be 1 over 33.
Oh.
You see what I'm saying? So there's a little thought process that you weren't using, which was if I want to make a fraction bigger,
Okay.
I'm not limited to adjusting the numerator. Because you looked at essentially the numerator being 3, you looked at it being 4, we talked about it being 5. All those things work, but not well enough, right? So it looks like the number that fits here is 1 over 33. Okay, so then we've got 1 over 32. And let's just check that 1 over 34 is in fact smaller. Checking 1 over 34 versus 3 over 100. How would you check that? Now we do get a common denominator.
We need a common denominator.
Yeah, I mean, I think
3, 4, 0. No, we can get a better one.
I mean, we don't have to like get really specific with it. We don't have to have a good one just to compare them. I'm just going to use 3400.
Okay.
So this would be what? 100 over 3400. That one is easy. Versus, how do I make this one have a denominator of 3400?
Times 34.
Right.
And what do I
Okay.
say times 34 is?
102.
102.
Yeah. Okay. So in fact, this is smaller.
Smaller.
Okay. So we
So
found
2
that
over 3.
we found that critical dividing line, and it is in fact where we picked. So now, finally, we've done all the hard work. We have to do the easy work, which is how many numbers are there in this list? I'm starting at 3 and I'm ending at 33.
31.
31, right. 33 minus 3 plus 1, don't forget that. And that's the right answer, right? So, and you're pretty, you remember, you know why? It's because when I do 33 minus 3, even if you don't know, let's put it, even if you do know, let's put it on the picture here. So, here's 3, and here's 4, and here's 5, and then this is actually a good lead-in to the next problem. Here's 32, and here is 33. Okay, 33 minus 3 counts the gaps. In other words, what I'm counting is this thing, and then that thing, and there are 30 of those, right?
Okay.
In other words, we travel 1 mile, then 2 miles, you know, imagining we're walking along 3 miles all the way up to 30 miles.
Okay.
But how many signs did we pass along the way? We started with one here. So we actually pass one more sign
Okay.
than we do. Do you understand what I mean when I say miles and signs?
Yes.
Okay. So think about this. Like if I just drew the picture.
At the first mile, when you start, there's no sign.
Exactly. So what if I drew the picture like this? I separated it and I grouped each mile with its own. Congratulations, you've just completed a mile. All right. So like as we're going along, we do 1 mile. Congratulations, right? Okay. So what's happening is, how many signs are there? Exactly the same number as there are miles. But we forgot about that one, right? So that's why we do 33 minus 3 plus 1 counts. I call these the posts, right? So I made the fence analogy. Like these are these are fence gaps, and then these are fence posts.
Okay.
Okay? All right, so a little extra factoid there at the end. All right, but so the answer was 31. So we have to make sure. There we go. All right.